Hi folks, now today I'm afraid we're not going to be doing much in the way of starter. You can have a quick look there and see my Knight's Tour. Now there's a few gaps in there because I've got to admit it all went wrong in the end. So I thought I'd done it, I thought I'd smashed it, and I got carried away and I put in a load of numbers in the wrong place, and it's got to that point where I thought, oh, I could start again and show that tenacity to keep going. But every now and then you have to say, oh, life's a bit short, let's just get another puzzle. So we will have a look at another puzzle, maybe next lesson, but today we've got quite a bit to talk about, because for one thing, the way you've been submitting work is great, and a lot of you have got into the habit now of just submitting it for when I said I'm going to give feedback on stuff. I've been told that I'm not meant to be doing it quite like that, and I'm meant to be asking you to submit something for every lesson, not to give you feedback on more than I have done already, but so I will be giving you sort of feedback on a lesson to lesson basis as a class, and whenever I ask you sort of once a week to upload your attempt at something, I'll try to give you feedback on that personally, but most of the feedback is going to be given back sort of in these videos. But what I am going to be doing is every single lesson, if you don't want to get a work not submitted against your name for that lesson, you need to upload something to me. I won't necessarily show you something about it, but I will load it as submitted, and I will also give you a positive for doing it. Okay, right, so I hope that's clear, will sort of make sense. So every single lesson, just put something of what you've done up there, and if I've asked you for something specific which we haven't gone through yet, then obviously that's what I want to see then. Right, now we've got two different questions from previous lessons to go through before we carry on with the main stuff, which is going to be finding the area of a sector, and then even a segment maybe right at the end if we've got time. Right, so when we were doing those composite and inverse functions, I asked you to have a go at this question 7. So working out an expression for the inverse function of g, all we need to do is say let y equal g to the minus 1 of x. So then we say, sorry, we let y equal that. So we let y equal x plus 3, and then all you have to do is make x the subject of the equation, which we can do by taking 3, because the inverse of adding is taking, and then we replace the y with the x at the end. So the expression for g minus 1 of x is going to be x take 3. Yeah, so that is going to equal x take 3. If you just write x take 3, that's okay, because they've just asked for an expression. Right, the next one for the function of f, slightly more complicated one. So we've got we're going to let y equal x squared take 17. We're going to add 17 to both sides, and then we're going to undo the square, which we do by rooting, and it gives us the root of y plus 17. Have I gone through this already? I might have done. Oh, I'm suddenly getting deja vu. If I have, so it's going to be the root of x plus 17, and you don't need to put plus or minus there, because it's not, because you're only going to have one value that you could have come from. So that's where you get into something called domains, but you don't need to worry about that until A level. Right, so the last one, we're solving this equation for that one equaling the other one, which was x take 3. So first up, we need to square both sides to get rid of the square root, and that'll give us x plus 17 on the left, and it'll give us x take 3 squared there. Now that means x take 3 times x take 3, doesn't it? Which gives you x squared, 2 loads of minus 3x, which we can peanut, and plus 9 for there. So it means we've got x plus 17 equals x squared plus 6x plus 9. And then what we have is a quadratic equation which we need to solve. And to solve any quadratic equation, you need to make the equation equal to 0. So I'm going to take the x and I'm going to take the 17 as well, which is going to leave me with x squared plus 6x take 1x is 5x. 9 take 17 is negative 8. So that's what we're trying to factorize now. And then the brackets we have to make equal 0, don't we? So 8 times, have I done something slightly wrong here? Because I can't factorize it. So let's look back. Hang on, negative 3x plus negative 3x is negative 6x. So when I take x away from that, I'm going to actually have negative 7x take 8. So I'm looking for two numbers that multiply together to make negative 8, but the difference between them is 7. Now you can only do 2 times 4 or 8 times 1. So the difference between 8 and 1 is 7. We want it more, we want the bigger one to be negative to make minus 7. So negative 8 plus 1 is minus 7. And negative 8 times 1 is negative 8. So x minus 8 equals 0, or x plus 1 equals 0. X must equal 8 if it's that one, or x equals negative 1. And that's all you have to do. Just write both solutions like that. Okay, then last lesson I asked you to have a crack at doing this one on your own, and some of you have done some really great solutions for this that I'm pleased about. Everyone's pretty much got the idea that first up what you're trying to find is the second difference. So the first difference there is 19, and then from 18 to 47 that would be 30, it would be 29, and then 39, and I think I can see a second difference there. My second difference is 10 from 19 to 29 and 29 to 39. That means, so the second difference equals 10. We divide that by 2, gives us 5n squared. So part of our solution is going to be 5n squared. Next thing to do is to work out what 5n squared is. So I'm going to begin with n being 1, 2, 3, 4. Therefore n squared is 1, 4, 9 and 16, and it is worth having these just 1, 2, 3 and 4. It may well help us out later on. Then I want 5n squared, so I'm going to times everything by 5 to give me 5, 20, 45 and 80. And before I do anything else, I'm going to bring my original sequence down below and look at what's the difference between 5n squared and this, and then I'm going to be looking to tag a linear sequence, a straight line sequence, onto that. So let's pick another colour and look at what we've got. So from 5 to negative 1, that's taking 6. From 20 to 18, that's taking 2. From 45 to 7, that's adding 2. And from 80 to 86, that's adding 6. So now I'm going to look at this sequence here: negative 6, negative 2, 2 and 6. And then I'm going to say, well, what are the differences that we've got going on here? The difference between negative 6 and, well, that's going up 4, and this is going up 4, and this is going up 4. So on a normal nth term, that means it's going to be 4n plus something. So plus what? Well, if you write out your 4 times table, 4, 8, 12, 16. What do we have to do every time to get from there to there? It's 6 add 10, 2 add 10, negative 2. Yeah, add 2 and then another 8, so that is adding 10, and that is adding 10. So it's negative 4 add 10. So our final solution is this bit added to this bit. So it's 5n squared plus 4n hang on, is it plus? I'm just thinking, no, because I'm going from 4 down to there, aren't I? I'm going down, I want to get to that. Sorry folks, so I'm not adding 10, am I? I'm taking 10. The reason I suddenly realised I'd made a mistake there was my sequence starts with a negative number, so something has to happen to make that happen. When n is very small, squaring it and timesing it by 5 when n is just 1 isn't going to do quite as much as taking 10, but after that, once it gets bigger, all of a sudden it does. I hope that helps and wasn't too tricksy for you. If you are confused by it, go back to last time's video and have another look at it, but don't worry too much. As long as you can get to that second difference bit, it's all about picking up some of the marks on these high grade questions. Right, now we've used half our time going over other stuff, but that's okay because what we're going to do today is not that tricky, so we should be able to go through these quite quickly. Pause the video, make a note of what's going on, or print it off if you can, and then see if you can think what you could need to do. First things to think about is the area of a circle is pi r squared, and with a sector, that is a portion of a circle. This is always the center, so the radius is 8. And the first thing to think about is the sector is going to be a fraction of that circle. And all you need to think about is the fact that a circle is made up of 360 degrees. So what we want here is 150 360ths of pi r squared, of meaning times in maths. So you've got pi times the radius 8 squared, and you can whack that into your calculator in one go like this. Hit the fraction button, 150 over 360 times pi, which is shift and this button right down here at the bottom, and then multiply that by 8 squared. Just pop it all in like that. It gives you that. If they want the exact answer, that's what you have. Otherwise, you hit S to D, and that turns it to a decimal number for you. 83.77. Now, it says 3 significant figures, so I'm writing down the first 4 figures on my display, and then I can show my rounding up, and because that's a 7, that pushes this one up to make it closer to 83.8 than to 83.7, and the units, because it's area, are centimeters squared. Now this next question, take your time, pause the video and work out what it's asking, because it's slightly different. The length of the arc is this bit, which is not going to be a fraction of the area but a fraction of the circumference. The circumference of a circle is, pause the video and write it down, C equals pi d, where d is the diameter. So if 18 is the radius, the diameter will be 18 times 2, which is 36. So if you wanted the whole circumference, you would be doing pi times 36, but you don't. You want this. You want the same idea, this fraction of that. So put that into your calculator, and you should get 25 over 2 pi, and it says give your answer in terms of pi. So 25 over 2 pi centimeters is your answer. Okay, now I'm not going to do massive amount of talking through each bit here. I'm just going to let you pause the video, have a go, and then I'll put my working up there. So you should have got this fraction of pi r squared, giving you 332.6, which rounds to 333 centimeters squared to 3 significant figures. Moving on, question 4. Pause this one and give it a go. You may have done this as 1/6, but you put all of that into the calculator and you do actually get 2 pi. So this is probably a question that would come up on a non-calculator paper. Whenever it's done in terms of pi, that generally is it. So from now on, every question that we've got that is asking for it in terms of pi, we're going to do without a calculator. When it asks for significant figures, then we use a calculator. From now on, there's going to be a fairly short amount of time for each question for you to pause, have a go, then I'll just put my working on with a minimal amount of explanation. So pause it now, give it a go. So we've multiplied it by the fraction of a circle times pi r squared, gets you 211 square meters. Question 6. Pause it, have a go. You can use a calculator on this because it's to significant figures. Pause it now. So this question was a little devious because it wasn't asking you for just for the arc, but for the perimeter. So it's the 2 pink straight lines as well as the yellow arc. So there's your 2 straight lines plus that. Stick it all in your calculator in one go, and that counts as your full working, rounded to 17.7. If I make any mistakes or you think I've made one, please let me know. I'll give you positives for any correct spottings of mistakes. I do make them every now and then. Question 7. Find the shaded region. Jot it down. Have a real long think. In 3 seconds time, I'll give you a hint if you're stuck. Right, so if you're stuck, to get a shaded region, you want to think about the whole of this, which is a quarter of a circle, and then you need to take away the area of this semicircle. Pause the video now before the solution starts coming up. So this is in terms of pi, so it's without a calculator. So for the quarter circle, the radius of the big circle that would all be part of would be pi times 10 squared. So it's a quarter of pi times 10 squared. We're going to be taking away a half of this smaller circle whose radius is just 5 centimeters. So a half times 5 squared. So I've then thought 10 squared is 100, a quarter of that, 100 over 4, I've written that pi, take 25 over 2 pi, just treat pi as if it's x or any sort of unknown, and then 100 divided by 4 is 25, and this is a half of 25. So if you take a half of 25 away from 25, you've got a half of 25 left. So you've got 25 over 2 pi, or 12.5 pi, or 12.5 pi, whichever you prefer. Okay, pause the video and have a go at question 8. I'm not going to give you any clues. I'm just going to put my working up in 5 seconds. So, very quickly, the area of the rectangle is 180. The area of the shaded is 180. Take the area of the semicircle, which is a half of that circle. That gives you 123.45 something. To find that as a percentage of the rectangle, you write that area over the area of the rectangle, which gives you a decimal, multiply it by 100. 68.58 rounds to 68.6%. And I think that's where we're going to leave it for today, because that's been fairly full on. We're going to start with this question next time. So have a think about what could happen for that. It's going to take some more thinking and using of formulae. Cheerio everyone, see you tomorrow.